Let's go ahead and begin our custom component by modeling in a contour plate here along this beam. So I'm going to make sure that my snap to geometry lines and points is on, and I'm going to snap to the inside of the flange and the web here. So we'll just go down to the bottom and then here, and after my 4 points are picked, we'll just middle mouse button to close out that contour plate. Now let's maybe come in here and change these chamfers real quick. So I'll just put in some values here to escape the beam radius. And then let's go ahead and even grab this one here and modify. And so now we've got some corner clips basically on that tab. Now let's go ahead and move this, and we'll come in here from this point, and let's just move this along the flange here. Let's go just 24 inches from the end of the beam. Okay, so we've now modeled in a stiffener here. And one other thing that I want to do is I'm going to actually make an insertion point for me to pick here, so that way I can easily place the custom component at the center line of the beam, since that's the easiest snapping point. So what I'll do is I'll go to the edit menu, and I'm going to say construction points here, and I'm going to use the construction point at any position. And then I'm just going to go ahead and say control left click here to set a reference point, and then I'll just go perpendicular to the center line of the beam, and now we have a point here in the model. And so again, that is going to be my picking point there at the top of that beam. So top center. Okay, the next step would be to actually define the custom component and wrap this stiffener up into a detail. To define the custom component, we'll come over here to the Applications and Components panel, and we'll press this button here and say Define Custom Component. Now, in the type, we can see here there are 4 types, and we covered this in the Introduction to Custom Components and Components video before this. Let's go ahead and change this to Detail, and we need to give this a name. So I'm going to say My Stiffener here, and you'll notice that the Next button actually disappears. And the reason is because every custom component name must have a unique name. So there's already a component in my model called My Stiffener. So we can call this My Stiffener 2 or some other name that's unique and different than something that already exists. Now on the Position and Advanced tab here, we're going to go ahead and change this from an end detail to intermediate detail. So again, as you saw in the previous video, an end detail would be something like an end plate or a base plate, or even an embed plate going to a wall that's going to be applied by picking either the left or the right end of the beam. Here, an intermediate detail can be picking a point anywhere along the beam, which is exactly what we'd want to do here for the stiffener. So we're going to change this from end detail to intermediate detail. We'll then press Next, and the objects that are going to be created by when we insert this custom component detail is going to be the stiffener. So we're just going to go ahead and select that and press Next. The part that we're going to apply this stiffener to, or the input part, is going to be this beam. So we're going to select that, press Next. And then lastly, there's the picking point. So the detail position, which basically means where should we locate this along the beam. Now you can use reference point here, which means that you're actually picking that. So wherever we pick is where the component's going to be lined up and added. Or if we said main part, basically means you don't pick any point, and the insertion point is based on the start point or the start end of the beam, which is the yellow point here. Now we want to actually pick the reference point, so we're going to use that as the option. And again, we added this point here in the model, so we're going to go ahead and get back into plan view just to make sure that I easily select that point. And then I know that's the point I want to pick, and then I just go ahead and press Finish. And now that custom component has been added here in the model. So again, what's great is I've got this cone. I can see this is all wrapped up, but there is a bug in Tekla Structures 2017. For some reason, I can't highlight that component that's just been created. So if I come down here to my selection toolbar, unselect, and then turn the selection back on, now I'll be able to highlight that cone. But what's great about this is, just like any other detail, if I delete that out, then the component disappears, including the plate. So let's undo there. And if we go into our Applications and Components, we can see there's the My Stiffener, which was the first one I made before, and then my new one here called My Stiffener 2. Alright, so let's go ahead and say that we wanted to apply this component to other locations on the beam. I'll just simply click on the My Stiffener icon here in the Applications and Components panel. I'm going to change my snap here and turn Snap to Geometry Lines and Points off. At the lower left-hand corner, it's prompting me to pick the beam or the main part, so I'll go ahead and pick the beam. Then I'm going to right-click and say Snap to Nearest, and I'm going to be snapping here along the center line of the beam. Now I'll just repeat this process a few times here. Okay, now we notice something that's kind of strange. When I pick over on this side of the beam, it's actually putting them on the near side, and when I pick over there, it's on the far side. So that's not exactly what we want to happen. So if I double click on this, this is something that's been around in Tekla for a long time. Even though we specified intermediate detail in the dialog box, you do have to come in here if you truly want it to be an intermediate detail and you're putting these in, you're going to have to come in here and switch this to intermediate detail. And then this will make sure that it's exactly on the side that you had picked when you defined the component. Now, also as a good practice to make sure that that sticks, every time you apply the component by default in the model, if you come in here and type the word standard up here on the save as, that will remember and load that up as a default every time you apply that custom component. Okay, now there is a case of, well, let's say that we actually wanted these to be on the other side. So you can select, and in fact I'll select one on this side of the beam and this one over here on the other side. And then if we switch this to intermediate detail reverse, that will just basically rotate that 180 degrees and basically put it on the far side. So this is a nice way with intermediate details how you can use or design something to work on the near side, and then it can quickly be rotated or used in an immediate reverse or opposite side. Now, multiple details can be applied in the same spot as well, so this is something you have to watch out for. So let's go back to immediate detail and press apply, and then let's go back to my stiffener 2. We'll pick the beam, and then we will pick that insertion point there. And now we have two components that are basically at the same picking point, but one is basically going to be set for intermediate and one is set at intermediate reverse. So there's intermediate, and then we have intermediate reverse. Now there's something you got to watch out for here is that you can actually say intermediate reverse on both of them, and now you have two details on top of each other. So this is something that you'll want to watch out for. Now you can kind of see here that when you see the two different cones, they kind of have like basically an extra shaded line, so you can see that there's two on top of each other. But this is kind of hard to see unless you're paying attention, so it's something you might want to watch out for with details. You can put multiple details on top of each other at the same location. Now that we've learned the basics of applying our component in the model, let's go ahead and start to make them parametric. You can either select on the component in the model and right-click and say Edit Custom Component, or over here in the Applications and Components panel, you can see on the icon here and right-click and say Edit Component. This is going to open up 4 new views here that are going to be prefixed with the title Custom Component Editor. You want to make sure that any changes that you do to your custom component are in one of these 4 views. You don't want to be modeling in one of the main views in Tekla. So as a good habit, I usually either select this view and minimize it so that way it doesn't pop up here, and then if I just want to tile these component editor views I can, or as a good habit I also even fully close out any of those main modeling views. The reason why I show people how to minimize versus say you should close them out all the time is if you've got a really large model or a big model and it takes a long time to open views, then you may just want to minimize them versus completely close them. But the key here is that any editing or modeling you do for the custom component needs to be inside of these custom component editor views. Now what also appears is a custom component editor toolbar and a custom component browser. These 4 views in the model, they're actually created in a distant location inside of your existing model. It's like basically creating a temporary copy of this beam and this plate that we made here, and it's off in the middle of space. And then when you close the editor, it actually deletes those objects out of your model, and they basically disappear and they're not anywhere to be seen. So if we simply just want to close out of the editor, there's on the toolbar here a button that says close. And then when we do that, it's basically prompting us, you already have custom components with this name in the model. Would you like to save your changes and replace all the existing occurrences of this custom component in the model? And I'm going to say yes. So here when I save, basically any changes we did will be saved to the database. And if I bring back this view, any changes we would have done would have updated all of these instances of the component here in the model. Okay, so let's go ahead and repeat that again. If we want to edit the component, we can select it, right-click and say Edit Custom Component, or over here in the panel, we can right-click on top of the custom component icon and say Edit Component, and then it opens up these component editor views. Again, if we have any main modeling views that are open here in our model, we want to make sure that they're minimized so that way we're not modeling in those. So here we have the 3D view, and I'm just going to go ahead and make sure that that's minimized so that way I'm only modeling here in the custom component editor windows. Inside of the custom component editor, there are 3 icons that are pretty critical that you're going to use all the time. Let's say, for instance, the custom component browser dialog disappears. If you come onto the toolbar here and you hover over each icon, it actually gives you a tooltip telling you what those buttons do. Here, if we press this button, it opens up the component browser. All the component browser basically is it shows what are the objects that are actually included or picked inside of this custom component. So here the primary part basically represents the beam that we selected, or the main part. And so you can see that when I actually highlight something here in the browser, it highlights that in the model. Let's say that I go to the component objects. This shows that this is the plate that we actually created and that we selected to say that this is going to be created by this detail when we apply it to the beam. Then we can go underneath there and we can actually see some of the different properties. This is where we can actually link parametric formulas or fields from the dialog box to change any of these values. So for instance, you see profile here. If I open up the properties, we can actually programmatically or parametrically control this profile field or the name or any of these other fields that we see on the dialog. Okay, so that basically shows you the custom component browser. The next thing is the variables list. This is really important because this basically manages all of the parametric bindings that you have here in your component, as well as any fields or labels that we're going to show on our dialog box or inputs that we may receive. Now, in this custom component, I know that I may want the user to be able to enter in the thickness. So I'm going to go ahead and add a variable here. And if I go to the value type dropdown, there are a variety of different input types or field types that we can have on our dialog box. If we're asking for a thickness or a dimensional value, this is going to be a length type, and you'll be using that often. If we're looking for like the part name, then basically we would put in text because that's a string that somebody's going to enter in. If we're looking for the material catalog so the user can select or type in the material, we would choose material. So these are all the different types of inputs or data types that you can use. Now let's go ahead and do a default of 1/2 inch here. And then what I'm going to do is I'm going to change the label in the dialog box. And I'm going to go ahead and say plate thickness. So that shows you how easy it is to add and delete variables and the different value types. Now let's go ahead and delete this P2 out. And we have one other thing in here that we might change, which is the visibility. Do we want this variable to be something that's behind the scenes in a calculation internally? Or is it something that we want the user to be able to see on the dialog box and enter in a value for? Now in this case, we do want them to be able to enter that, so we're going to leave the visibility to show. But let's add in another parameter because we can't simply take the 1/2 inch here and put that as the profile value. So if we come in here, we see that there's a PL prefix for plate. Now what we're going to do is we're going to string together the 1/2 inch that the user tells us, and we're going to string that together with the PL prefix. So what we need to do is we need to go to the value type here, and we're going to say this is a type of profile. We don't want the user to have to type in the PL prefix, so we're going to set the visibility to hide here. And I'm just going to rename this for my own tracking as plate profile. Then what we'll do is we'll just come in here and we'll say equals, and every time you start a formula with equals, that's telling the editor that you're actually writing some sort of formula in here, and everything to the right of that equal sign is going to be that formula. So when we're doing a profile, this is actually a string of text. So we're just going to type in quotes because all strings of text need to be inside of a quote unless it's a variable. And so we're going to say equals quotes PL and then close quotes. And then when you're tying strings together, you basically use the plus symbol, which just joins different strings together. So we want PL plus the result of variable P1. All right, so once we've got that entered in, we can just hit enter on our keyboard, and we can see that the result of this formula is plate or PL 1/2. All right, so now when we change the P1 formula or value, you'll see that P2 automatically updates, and so it says PL 1 inch. Now, how do we get this P2 value to actually be parametrically linked to the profile property here on the plate. Well, here's how we bring in the custom component browser. We select on that plate, we go to the profile property here, and we can right click and say add equation. And this is where we take the P2 parameter name here, and we just set that after the equal sign and press enter, and now it's parametrically linked. So if we go into the model, you'll see that here in the editor view that it's actually changed this to 1 inch. And now if we go back here to 1/2, it modifies. Now there is some simple logic here, but isn't this really simple and easy? And guess what? You didn't have to do any programming or any code. Just some simple logic here of tying things together between your variables list and your component browser, and now you have something parametric in your component. All right, let's go check this out in our model. So if we go back to the custom component editor toolbar, we're going to close this. And again, remember it's saying that we're going to go update all of the instances of the component in the model. So we're just going to go ahead and say yes. And now when we go back to our 3D view here, we'll see that all of the components here in the model have this ability for us to come into the dialog box and change this from 1/2 to say 1 inch, or we can change this one here to say 3/4 of an inch, or we can change this one here to 3 inches. So basically here we can modify the individual instances of these components to change the thickness on each one of them individually. Or if we come in here, and now we have 2 on there, so let's get rid of one of them. But if we come in here, if we see that we haven't or entered a value in here, whenever you open up the dialog box from a component that's already in the model, if you see a value that's inside of brackets, that means it's using the default value that we entered into the component when we created it. So if we want to override that, which we do, then we're going to type in a value, say modify, and then it'll override that. If you actually want to go back to the default, you just simply clear out that variable, press modify, and if you want to see what it is, you just press get, and again, if you see it in the square brackets, you know that that's the default value built into the component. All right, let's go ahead and save our work, and then we'll go ahead and go to the next step. All right, so the next step here is let's go ahead and edit the component again. So we'll right click and say edit component. This opens up the editor, and again, I want to, on the 3D view, go ahead and minimize that so I know I'm only working in my custom component views. So we'll go ahead and tile these vertically here. And the next thing I'm going to do is I want to make this parametric so that way if the beam size changes, that I know the width and the height or the length of the stiffener changes. Now, the way that we model in a stiffener is we actually picked the insertion points. And if you move any of these points, that changes the geometry of the plate. So what we really need to do next is there isn't really any variable name or anything that controls this. This is more of a geometry constraint based on the profile and the geometry in the model. So what we're going to do next is a thing called binding. So we're going to select on this plate, and then let's just go ahead and select on one of these points. Now, what do we want to happen? If the beam size changes in profile, and let's say the flange gets wider, then we want this point to always follow the toe or the edge of the flange. And then let's say that if the beam flange thickness changes, we always want this point to be lined up with the bottom of the top flange. And then let's say that even along the length of the beam, we always want it to be lined up wherever the insertion point was. So now what we're going to do is we're going to constrain this, or we're going to bind it. So we'll right click and we'll say bind to plane. Now you can also interrupt here. The other way to do this is here on the toolbar there is a add fixed distance, which is basically adding a binding. I like to just do this because this makes more sense to me by selecting and then just saying right click bind to plane, because that's kind of what we're doing. So let's just do that. And here we can see that there are 4 different plane types, and I'm going to cycle through each of these so that way you know what each one means and why you would use it. Now, boundary planes basically means it's looking at the outside or drawing a box around the profile of the piece. So basically, as you go around the member, it's picking these surfaces as if there's a rectangle or a box around the part. Now, these are a little bit lighter weight than the outline planes, which are next, which actually go to each different face. So if you really just need to go to the edge of a material and you don't really care about going to the web or anything, then boundary planes is pretty good. If you want to go to the center line of the beam, then you can use center planes. So notice here that when I hover over, it's going to the center. And then there's a center along the depth, and then there's a center actually towards the midpoint of the beam. Now, we don't want to bind to the center here because we actually want to go to the edge. So there's another one here called outline. So if you don't want to just go to the box that surrounds the profile, you want to get to a very specific face on this shape, like the bottom flange or the face of web, etc., then you're going to use outline planes. Now there's also cut planes as well, which is binding to cuts and things like that. I don't use this very often, but that does exist. And then lastly, there is component planes. So component planes is basically three planes that are formed by the insertion point of where you picked to put the detail along the member, as well as basically it's perpendicular to the main part coordinate system. So you can see here as I hover over, it's at the center line of the beam because that's where I picked. It's also here along the length at the point that I picked, and then also here at half the depth of the member. Okay, in this particular case, we do want to bind to the component planes so that way the stiffener always comes to this point here wherever we picked. So I'll pick that. When I do so, it actually adds this little distance or binding here in the model. And if I go to our variables list, you'll see now that there's a D1. So whenever you do bindings, the name is always going to be prefixed with a D. Parameters or variables that you create will be prefixed by default with a P1, although you can change these names if you'd like to. Now, whenever there's a zero distance or a zero binding, because this point is basically right on the component plane of where we picked to put it in, it's centered on that, the D1 value or this distance value is 0. And whenever that happens, the visibility on the dialog box option is set to hide. Now, whenever there's a positive value, it will say show. So you might have to come in here and set that to hide if you'd like to. Maybe we'll see that here in a moment. All right, let's go ahead and select on this point again. We'll right click and say bind to plane, and this time we're going to bind to the outline planes. So the outline plane that we want to get to is the bottom flange, or sorry, the bottom of the top flange. So we'll pick that, and now we have another binding in here. Now, one thing that's important about doing bindings is that for you to select the surface to do the binding, you actually have to be in rendered mode. If you're in wireframe or if you're in even translucent, it won't necessarily allow you to do the bindings. So whenever you do a binding here in the model, you want to be in solid. All right, so let's get the last plane. We'll say bind to plane here, and now I'm going to bind to the edge of the beam. So we're binding this point in three directions. We want it to always be centered on the picking point to insert the detail. We want this point to always be lined up with the toe of the flange or this side of the beam, and we always want it to be lined up with the bottom of the top flange. All right, so what would we do on these other ones? Let's grab this, and we can right click and say bind to plane. Now we don't want to go to the exterior here on this one because we'd actually have to add or calculate a value. So if I do that, you'll see that there's a positive distance added here, and we can actually see that binding in the model. And if you go back to the variables list and we select on it, it highlights it in the list. And here's where you can see the visibility is set to show because it's a non-zero number. Now, we don't want to have to calculate a formula here, and so really what we want this to do is to be always lined up with the web. So let's just select this and press delete, and then we'll go back in here into the model. We'll select on this point. Again, we're going to make sure that we're solid, and then I'm going to right click and say bind to plane, and we're going to go to, you guessed it, outline planes. So again, the cyan or light blue plane, and we're going to go right to the face of the web there, and we'll get a nice zero distance or binding. We'll also bind this to the bottom of the top flange again, and if we want to, we can right click and say bind to plane, and we'll go to the center, or sorry, the component planes, so that way we can make sure that we're aligned with the picking point. So now at this stage, we should have a total of 6 bindings. And if you look over here, you can see basically the binding numbers and what it was binding to, the plane as well as the part involved. And so we've got the first 3 bindings involved with the top point, and then the second 3 bindings, the top point towards the inside of the web. Now, let's say that you want to bind multiple points at the same time to the same plane. If we go ahead and hold down Alt and window around these 2 points from left to right, it selects those 2 bottom points. We're going to right click and say bind to plane, and we want to go to the component plane here. Both of these bind to that component plane, so when I select that, now I have a D7 and a D8. Now, in retrospect here for the next points or the next plane, let's do that again, and we'll say bind a plane to outline, and we'll go to the bottom or the top of the bottom flange, sorry about that, because both of those points should be bound in that distance or that direction. Again, now we see D9 and D10. Now these last points though, or this last plane, we can't bind them at the same time. If we select on this, we right click and say bind a plane, this point needs to basically go to the outside, and then the other point on the inside here needs to be bound to the web. So we'll go switch this to outline planes, pick there, and there we go. Now, as a good test to make sure that you've gotten all of the points, because when you're first starting out, you kind of go, did I get all the bindings? Now you can luckily graphically see them here in the model, and when you highlight them in the list, it does highlight them in the model, so you can quickly check whether or not you've bound a point in all directions. And this is a suggestion I tell you to do, is does it mathematically make sense? You had 4 points and you have 12 bindings that you just did here, so it looks like you most likely got all of the points. But again, you can spot check by selecting and highlighting and then seeing where it appears in the model. Okay, so really that's all there is to it. We've got all the points now. Let's close our list. Let's close our component. And then I'm just going to go ahead and say yes to updating all the existing components in the model. We'll open up our 3D view here and check this out. If we go to the beam properties, we change this to something else like a W24 by 55 and modify, there you go. The components all update and they're parametric. Now what happens here if I copy this beam over? Here we can see that the details copied with it, but let's change this to a different beam, so W30 by 90 and modify. So again, all of the instances of the component and the part that they're attached to, or the main part or the input part, the components will modify to whatever they're attached to. So this is what's really great. Here within just a few minutes, we've been able to make it so that way we can change the profile thickness as well as the stiffener parametrically adapts to whatever beams that we attach them to. Now, how do we export this so we can share it with other users and other models? We're just going to go ahead and right click here and we're going to go ahead and say publish. And by default, it uses the same name and puts a .uel extension at the end. And it's going to export this by default to your model folder. So we're just going to go ahead and say save. And then there we now have the custom component exported. All right, so now I've created a new model here. And if we go into ungrouped items, we can see that there's no custom component here. So we'll just come in here and click on this button and say import custom component. Now I've got to go to my other model here. That is basically my custom component detail model. There's my stiffener2.uel file. I'll select and press open. And then now that has been imported into this model. If I go ahead and model in a steel beam here, so let's just pick 2 points. And then what we do is we just activate our stiffener component, pick the main part, snap somewhere along the nearest, and there we go. We now have our stiffener component and we can change the thickness if we'd like to. Now, some final words of wisdom here on our custom component. When you're making custom components that are specific for a job, or you may only use on a couple jobs and you're not using it everywhere all the time, basically I suggest decide exactly what needs to be parametric. Don't worry about making super duper components that have every attribute or everything parametric or binding everything in all directions. Only do the bindings and make parametric value fields that the user enters on the dialog box based on things that are going to change. Otherwise, if there's constant properties or things that are the same across the entire job, just leave those hard-coded as they are inside of the component. Only do the bindings or the value fields or the parameters of things that need to be parametric.